Okay, I'm going to go over a little bit of a practical example of ECS. And in this kind of a simple demo, I'm going to create two main systems, I think. So one is going to spawn ball, like random ball every kind of interval, or like, so every like some kind of 2 or 3 seconds. It's just going to create a new part, put it in workspace, and that's about it. And then I'll have another system that kind of iterates over the all of the ball, and then it kind of throws them up in the air. So we can use something like apply impulse for this. So this is not too difficult to do. And first things first, make sure you have JCS module and replicated storage, and then we can get started. So first things first, I'm going to import replicated storage. And let's import ECS as well. Now, I'm just going to create a quick type. This is just for types, right? Like we have Lua, you should be using types. It saves a lot of time. So now I'm gonna first create two components. Well, no, 3 components. Let's create it. So first component will be a part. Actually, no. Before that, I need to create a world. So typically in your project, you would only have one world, and all of your entities would just go inside this world, or you would rather create entities from this world. So let's create a 3 components. First component, I'm going to call it part. So world, should make this lowercase. Components, entity, and part. So what am I saying here? I'm creating a new component from this world, and I'm saying that this component should only have part as its data. Now I'm going to create another component called velocity, and it's going to take in vector. So the data type of this velocity component is vector. The last component I want to create is something called timestamp. And this timestamp only contains numbers. So we have our required components. So I'm going to create our first system. So first things first, we want to be able to spawn a kind of part and then attach it to the workspace. So this is a system name, and I'm just going to create a new scope and spawn ball. Now, what do I want to do here? I want to be able to first just create a new part. So I'm just going to say ball is instance.new part. Let's change the shape to ball, right? Then we want to be able to create, first before that, let me just create a color. Let's do color 3.rgb. I want to create like a random color, so I'll do something like, let's create a function, local function rand ab return math.random ab. I was going to do something like r, or actually, yeah, Yeah, that's fine. So let's just do 0 to 55, 0 to 55, 0 to 55. And then that's the color. Let's position as well. Let's kind of position it randomly. Vector.create. Oops. Let's do random position. So minus 10 to 10 for this. And minus 10 to 10 for this. So I want the y to be the same, but then x and z to be like random. And finally, I think we can just parent to workspace. Okay, now we created a part, but we haven't really done anything ECS related. So let's do that. I'm going to create a new entity. So this is just a container. And what it's going to hold is that it's going to hold this ball as a part. So let's set it. So in order to assign components, we use set or add. I'm going to use set because I need to assign data. If you don't need to assign data, you can use add. So let's set this and let's do E. This is a part and the data is the ball. What are we doing here? So the first parameter, argument is the entity, the container itself. The second is the component that's getting added to this entity. And the third is the data of this part or of this component. This component's data is a part. So you're assigning a ball to this part. And that's it. So something to keep in mind. Okay, before that, let's kind of execute this system. And to do that, we always run a system in a run service loop. So let's create a run service loop. So I'm gonna put this in heartbeat. And I'm just gonna call this system in a heartbeat. So if I were to run this, we see a bunch of parts get added. But then we're adding a little bit too much, so let's add a little bit of interval. So what do I mean by interval? I'm saying that I want to spawn a ball every 1 or 2 seconds. How can I do that? Well, there is a better way, but for now, let's not use anything else. Let's not use any functions. Let's just brute force our way. So I'm going to say interval time is 2. So every 2 seconds, I want to spawn a ball. And then I'm going to keep track of the previous time. So let's just initialize it with like the current time it runs here. And let's just do something like this. So let's get the current time here. Clock. This will give us the current time whenever the script reaches this line. And then let's just check to see if the difference between current time and previous time is less than the interval time. So if current time minus previous time is less than the interval time, then we're saying that if it's less than the interval time, we don't add any part. So if I were to do this, try it out. Oh, I made a mistake. We're never setting the previous time. We're never updating the previous time when we do create it, so we should do that. Priv time is current time. So now if we see here, we only spawn a part every 2 seconds. Great. Now, the next thing I want to do is create a system that throws the ball in the air. So I'm going to create a system called maybe apply force system. I don't know. apply force. Yeah. Yeah, I guess that's fine. And I also kind of similar to whatever I did here, I also want to kind of apply the force every x interval, right? So let's do that. Local interval time to, let's do 1. Priv time, stop clock. Function apply force. And in here, what we will do is we want to query over all the existing parts in the world. So to do this, we can query. We can use something like query. So to do this, we do something like this for world query dot iterate do. So this creates a query. And the first thing a query always returns is the entity. Again, entity is just a container, so it's just a number, right? It's not a data or anything. Then inside the parameters, we can pass in whatever components we want to iterate over. So what components do we want to match with the force, this thing? Well, we want to be able to match a ball part and velocity, right? And then when we match these two components, we will receive them as well, right? We will receive their data. So in here, for all the entities that are matched with part and velocity, we want to update. We're going to apply impulse to the part with whatever velocity we specified. So it's just that. Now, let's just make sure that we update the. We also run this only for this interval. So let's do that. Current time is os.clock. If I'm just gonna copy this code actually. It's the exact same anyway. Blah blah blah. And then in the case that it does happen, we update the prev time. So this actually needs to go outside. For now like that. And then I will do this and then prev time, current time. Now, ideally you should be, since this is like applying impulse and stuff, it should be done in stepped, I believe. So I'm just gonna create a new event and run this here. Okay. And we will notice that nothing happens, right? Nothing is happening. Why is that? And that's because the entity does not have a velocity. So we never added a velocity component here, which means whenever we are querying over these two, we never come across an entity that has both part and velocity. So this will never run, essentially. Now, in order to make it run, we can just add a velocity component to our entity defined here. So the velocity, I'm just going to do something like vector.create 0, 100, 0. So we're shooting up in the air. Now let's run this. Now we'll see that it's getting thrown in the air. Something to keep in mind is that we're applying impulse all at the same time. Even though it doesn't look like it, that's what's happening. And that's because this is kind of not unique to the part, right? So I want to make this random. And in order to do that, I'm going to use this timestamp component. So what I'm going to do is I'm going to add an additional component here. Timestamp and add the current time, right? Like that. And I'm gonna kind of remove this code. Let's remove this as well. And here, let's wait. Yeah, okay. I was like, did I remove the wrong code? Nah. Okay. Anyway, so I'm gonna do this and do that. And instead, I'm gonna match the timestamp as well. So let's get the timestamp here. This is the priv time. Now, what we will do is, okay, wait. Maybe not. I'm so indecisive, but I think it's fine because we can just copy this. There we go. So I'm just gonna add this in here. Now, interval time, we need to specify interval time. I'm gonna specify this inside here. Interval time is, let's say we wanna apply force every 1 second. Okay. And then we're gonna update the previous timestamp by using the ID timestamp, which is the component, right? The component we want to update, and then we're going to update this by our current time value. Okay, now there is one big mistake I made, but let's run this first to see what that is. Maybe we can see it visually. Okay. You see how it's still very kind of uniform? That's because if whenever it comes across the first entity and it sees that the interval it's less than interval time, we're returning it. But this is wrong. We shouldn't be returning it. When we do return, it does not kind of iterate over the remaining things, right? What do I mean by that? Let's say we kind of matched against 5 entities. If the first entity does not pass this condition, then we want to skip over that entity. We don't want to return it completely. So this is where we should be using continue, not return. This is a very common mistake while working with ECS, is that people use return when they should be using continue, right? So whenever you're in a query, most oftentimes you want to be using continue, not return. But in this case, since we don't have a query and we're only doing this once or like once every whatever frame, this is where return is okay. And that's it. That's our kind of system that kind of throws the ball up in the air. And it's pretty randomized. So let's just kind of make it such that 2 seconds is a little bit too much. Let's make this 1. Let's do this every 0.25 seconds. Make it more fun. Whoa, it's going all the way up in the air. I think I would want to make this randomized. So let's do like anywhere from 10 to 100. Let's do that. So it's a little bit more random. There we go. Now we can even update the velocity. Oops, that I didn't mean to do that. We can create a new system that kind of just updates the velocity every whatever seconds, whatever. I'll leave that as like an exercise, and then we can kind of, you know, go over it on the next video maybe. But the idea would be very similar to something like this, or even something like this, whichever way you would kind of want to prefer doing. Essentially, you would just need to query over only the velocity and timestamp, and if the timestamp matches with whatever time interval, then kind of update the velocity, and that's about it. Now, one last thing. This way, since this is something very common to do in ECS, there's a better way of doing this rather than doing it like this way. That's to create like a helper function. So I'm going to create a function called interval, which takes in a time. So essentially, this is saying that this point of this function is that every specified t time, we will kind of execute something. So what I'm going to do is let's create a track of variable previous time. So move this here. I'm going to return a function that's going to tell us whether we should execute this or not. And we can do this by returning a Boolean. Let's keep track of the current time. So this part, let's bring this here, right? Instead of t time, it would be this. Let's assign a variable. Should I think has elapsed, maybe. That makes more sense. Is just current time minus brief time is less than this. Then, if it has elapsed, we want to update the previous time to current time, and just return has elapsed. So how would we use this? Let's create an interval of something like this. Should spawn ball is interval every 1 second. And since it returns a function, we can just do something like this. If should spawn ball, then if not, I prefer writing it this way. And we don't need to update anymore. And yeah, this is a very useful function to have, especially if you're doing ECS. You will come across this a lot. So it's great to kind of keep it in your utility. Oh, something. Did I change something? Why is it? No, it's fine. I think I just let's see. Did I change something? T oh. Current time minus brief time is greater than, yeah. Careful about that. I was like, why? We only want to update this when it's greater than this interval. And yeah, it should kind of work. There we go. So every 1 second, we're spawning our ball. Cool. And yeah, that's it.